Good morning, boys and girls.
Today we're going to do 11-2, make line plots. I can represent data using line plots.
Let's look at the solve and share. In a class of 27 students, 5 students have 1 pet. 3 students have 2 pets. 4 students have 3 pets. 2 students have 4 pets. 1 student has 8 pets. The remaining 12 students do not have any pets. Are there any outliers in this set of data? Explain. Ms. Schultz, that's a lot of numbers.
Sure is.
What is this question asking us to find?
So I need to find if the data set for the number of pets has any outliers.
Great. What do we already know?
We already know that there are 27 students and the number of pets each student has. And Ms. Ortiz, before we go ahead, I just want to remind everybody that an outlier is any number in the data set that is very different from the rest of the numbers.
Great. So that's what we're looking for. How can we look for that just with this big word problem with all these numbers in it?
I think our Bitmojis are trying to tell us something. A line plot can help you be precise and organize your data. So we know we have a bunch of data within the word problem, so I think it's best if we go back and reread the word problem and we can start labeling our line plot with the data in the word problem.
Okay, I'm going to use X's to mark how many number of pets each student has. So when we read the problem over, I'll put the X over each number.
Perfect. So I'll start reading it again. In a class of 27 students, 5 students have 1 pet. So Ms. Ortiz, I think we should stop there and find the number 1 on the line plot. And we know that 5 students have only 1 pet. So we need to put 5 X's on our number 1 line plot.
So 1, 2, 3, 4, and 5.
So 5 students have 1 pet. Let's keep reading. 3 students have 2 pets. So let's move to the number 2 on the line plot and put 2 X's. Oops, I'm sorry, it's 3 X's because 3 students have 2 pets.
Perfect. Next.
4 students have 3 pets. So if we go to the number 3 on the line and we put 4 X's because there's 4 students. 2, 3, and 4. Great. 2 students have 4 pets. So go to the number 4 and let's put 2 X's for 2 students who have 4 pets.
Perfect.
And 1 student has 8 pets.
So is that going on the 1? Where does that go?
We need to find the number 8 on the number line because that's how many pets the student has, and only 1 student has 8 pets. The remaining 12 students do not have pets.
So if they do not have pets, Ms. Schultz, it's like they have 0 pets, right?
Correct. So we should show 12 students on the 0 number lines, on 0 point. 0 and 12 X's for 12 students having 0 pets. Five, 6, 7. I hope you could fit them.
I know.
8, 9, 10. You can put them on the side to the left, Ms. Ortiz.
And I
11.
think I could fit 11 here.
Oh, perfect.
And then put 12 right up here.
There you go, 12.
Make sure you leave enough room, boys and girls, when you're making your line plot. So,
okay.
If we go back to the original question and what we need to find, we're looking to see if there's any outliers in this data set. What do you think, Ms. Schultz?
So, looking at the data set, I see a lot of data on the line plot between 0 and 4. And then I see only one X all the way down by 8. And in my opinion, 8 is an outlier because 8 is not close to 4, and it has one piece of data there, and it's further away from the rest of the data. So 8 is an outlier.
Okay, so we have 8 as an outlier because it is far from all of the rest of the data. Great
Correct.
job. Let's try another one. Complete the line plot. What is the most common shoe size? Which is the outlier?
Okay. So it looks like we have a data chart there that says shoe sizes: 4.5, 5.5, 4, 6, 7, 5.5, 10, 6, 8, 5.5, 6.5, 5.5. So Ms. Ortiz, I'm noticing that some of the numbers are being repeated, which means that there's a couple of people that have the same shoe size.
So I was thinking we could use these slashes here to mark the numbers as we go.
Perfect. So remember that the number of X's that we make on the line plot will represent the number of shoes that are that size.
Perfect.
So let's start plotting. So the first, if you notice our line plot, we started with 4 because that was the smallest number in our data set. And then we ended with 10.5 because that was the largest number in our data set. So let's start with the first number, 4.5. So Ms. Ortiz, let's put 1 X above 4.5, and let's cross it out in our data set.
Are there any other 4.5s here to plot?
Nope, doesn't look like it. Oh, but I do see a 4.
Oh, got it.
So let's cross that 4 out, and let's put an X above 4.
It's very important that we make sure we cross it out. So, and then put the X so we know that we get all the numbers.
Right. So now I'm noticing so far that one person has a size 4 foot and one person has a size 4.5 foot. So let's keep going. Our next data number is 6. And I'm also noticing in the data chart that there's more than one 6. So there's 1, so we can put an X for that one. But then I'm noticing that there's another 6 there as well next to the 10. So let's cross that one out and add another X for 6.
Perfect.
So going back into our data chart, after the 6 looks like 7. And that's the only 7 I see in the data chart. So let's put 1 X above 7. Okay, 5.5. Looks like there's 5.5. 1, 2, 3, 4 times. Wow. So let's cross out 5.5. And we need to put 4 X's above 5.5. So 1, 2, 3, 4.
Perfect.
Okay, next one is 10. And I only see one 10, so let's put 1 X above 10. And then I see an 8. Let's put 1 X above 8. And then the last number in our data set is 6 and 1/2. So let's cross that out and put 1 X above 6 and 1/2. Great.
So we go back to the question. It's asking, what is the most common shoe size? Again, I'm seeing a keyword common. Can you remind us what that means?
Yeah, so common means would be the shoe size that we see most often. What do most people have out of all the people in the data? So remember that the number of X's refers to the amount of people that have that shoe size. So what I'm noticing is that under 5.5, they have the most X's, which means that most of the people have a 5.5 size shoe.
So common could also be the one that has the most X's.
Yep.
Wow.
Like the common's like the most popular. So I would say like 5.5 is the most popular shoe size because there's 1, 2, 3, 4 X's, and all the other number sizes have less X's than 5.5.
Great. Let's look at the second part. Which size is an outlier? So do we see any outliers in this data set?
I do see an outlier. I think that 10 could be an outlier because it's 2 away from 8 and it's not close in with the rest of the data like the other X's are. So I would say that 10 is an outlier.
Yeah, most of the X's are at 4, 5, 6, 7, 8, and 10 is pretty far away.
Yeah.
So size 10 is the outlier. Great job. We can move on to the next one. Complete the line plot. Is there an outlier for the data of Sandy's pencils? Explain.
Okay, so here we're going to measure, we have data on the length of Sandy's pencils, and we have a data chart there. So what we could do is we can use X's to plot the data on our line plot. And I noticed that our line plot starts at the number 5 and goes to the number 7, and it's also broken up into fourths, just similar to a number line. So let's look at our first piece of data. It says the red pencil is 6 1/4 inches. So let's put 1 X above 6 1/4. And good idea, Ms. Ortiz, with crossing out to remember that we did that one already.
Yeah, I wouldn't want to double plot.
No, because then that would mess up our answers. So the next one, the blue pencil, is 5 1/4 inches long. The green pencil is 6 3/4 inches long.
Purple?
And the purple is 5 3/4 inches long. Orange is 6 3/4 inches long. And yellow is 6 2/4 inches long.
So if we go back to the question here, oops, it's asking us if there are any outliers. So if we look at the data over here and look where the X's are placed, do we think there's an outlier?
No, I don't think there's an outlier because the data is all close together within the same distance numbers. So like 5 1/4, 5 3/4, 6 1/4, 6 2/4, 6 3/4. All of those numbers are very close together. So there is no outlier. There is no piece of data that is not similar to the rest of the data.
I have a question for our students. Could they give us a number that they think might be an outlier if it were a length of Sandy's pencil? Okay.
That's how you make a line plot.
See you next time.